Problem 3.5.18. Solve differential equation by variation of parameters. In class, we talk about 5 different steps to solve this problem. So let's go through those 5 steps. Step number 1. We need to put that into standard form. So standard form is y double prime plus 1 over 2y prime equals 3x. So basically we want to make this coefficient to be 1. Find x equation, that is m squared plus 1 over 2m equals to 0. Factor out m plus 1 over 2 equals to 0. Now we have m equals to 0 and m equals to negative 1/2. Based on this, we can find y sub c complementary solution. Yc equals c1 times e to the 0x plus c2 times e to the negative 1 over 2x. That is c1 plus c2 e to the negative 1 over 2x. We need to identify y1 and y2. So y1 equals to 1, y2 equals to e to the negative 1/2. So now we can move on to step number 2. We need to calculate w1 and w2. So for the w, we need to put y1 and y2. Okay, that is 1 and e to the negative 1 over 2x. And then next line is going to be y1 prime, y2 prime, and then AD minus BC negative 1 over 2 e to the negative 1 over 2x minus 0. And then W1, the first column, we're going to put 0 and the right-hand side of the equation. So the first column, I have a 0 and 3x. And then second column is the same. And then AD minus BC W2, you're going to keep the first column. Second column is going to be 0 and 3x. AD minus BC. Step number 3. U1 prime is W1 over W. W1 negative 3x e to the negative 1 over x over W e to the negative 1 over 2x. Negative 3 over negative 1 over 2, that will give us 6, and then x, and this e to the negative 1/2 x, e to the negative 1x, they are cancelled out. U2 prime is W2 over W. We have a W2 as a 3x. W is 1 over 2 e to the negative 1 over 2x equals, now 3 over 1 over 2, that is negative 6x. And the denominator e to the negative 1/2 x, bring it to the numerator. Change the sign of the power, that is 1 over 2x. Now we need to calculate u1. So integral of this guy, that is 6 times 1 over 2x squared, that is 3x squared. That's easy. For u2, we need to integral for this. For this guy, we need to let u equals to x, and then dv equals to e to the 1 over 2x dx. From here, du equals to dx, and from here, v equals 1 over 1 over 2. Therefore, that's going to give us 2 e to the 1 over 2x. And then we need to multiply this way. U2 is going to be, we have a negative 6. Don't forget that. And then x times 2 e to the 1 over 2 uv. And then minus integral v du, 2 times e to the 1/2 x dx. Let's distribute this. Negative 12x e to the 1 over 2x minus minus plus 12. You take the integral of e to the 1 over 2. So 12 times 1 over 1 over 2 to the 1 over 2x. Then we have 12x e to the 1 over 2x plus 24 e to the 1 over 2x. Step number 4, we need to have a yp equals u1 y1 plus u2 y2. Previously, we have a y1 as a 1. We have a y2 e to the negative 1 over 2x. Yp equals u1 3x squared times y1, and then u2 negative 12x e to the 1 over 2x plus 24 e to the 1 over 2x times y2 e to the negative 1 over 2x. Distribute this, then yp equals 3x squared minus 12x e to the 1 over 2x times e to the negative 1 over 2x plus 24 e to the 1 over 2x times e to the negative 1 over 2x. And this will give us 1. Therefore, yp is 3x squared minus 12x plus 24. And step number 5, we need to put y equals yc plus yp. We have a yc as c1 plus c2 e to the negative 1 over 2x plus yp 3x squared minus 12x plus 24. Now we have a two constant terms. We can combine these two. That is, I'm going to let c3 plus c2 e to the negative 1 over 2x plus 3x squared minus 12x. So that's our answer. The same problem, we can solve this using undetermined coefficient method in the previous section. So differential equation is given y double prime 1 over 2y prime equals to 3x. Based on auxiliary equations, we found y sub c as c1 plus c2 times e to the negative 1 over 2x. Based on right hand side, we need to let yp equals ax plus b. However, we cannot do that because there is overlapping. There are two constant terms. So we cannot do this. So now we need to let yp as ax squared plus bx. Okay, so we multiply x. So increase the degree of x by 1. And we don't want to have the constant term because we already have a constant term at y of c. And we have double prime and prime. Yp prime is going to be 2ax plus b. Yp double prime is going to be 2a. Y double prime plus 1 over 2y prime. So y double prime equals 2a plus 1 over 2ax plus b, which is y prime, and that has to be equal to 3x on the right hand side. Then 2a plus ax plus 1 over 2b equals to 3x. That means we have a 2a plus 1 over 2b. That just the constant term should be 0. And we have ax, a has to be 3x. That means a has to be 3. So you plug it in here. That means 6 plus 1 over 2b equals to 0. We have a b equals negative 12. Yp we have here ax squared plus bx. Therefore, yp equals to a 3x squared minus 12x. Okay? And then we have y equals to yc plus yp, y equals yc c1 plus c2 e to the negative 1 over 2x, and then yp 3x squared minus 12x. So this is the same as here.